Hi everyone. So these are the contents of my presentation. I would like to start off with the introduction. So the methods of proof basically has two divisions, that is direct proofs and indirect proofs. And indirect proofs are further divided into contraposition and contradiction. I will be presenting the topic direct proofs over here. So direct proofs can symbolically be represented as P implies Q, that is if P then Q. So this is the hypothesis for my theorem, that is, suppose that n, m are even integers and a and b are integers. I have to prove that the sum an plus bm is even. Now I'm assuming that p is n, m are even integers and a and b are integers. And q over here is the sum an plus bm is even. So as you can see that n and m have some specification that they are even integers, but a and b do not have any specification. So they can be either even or odd integers, or they can be a combination of both. So I'm using the method of cases over here to prove my theorem. So case 1 says that a and b are odd integers. So by the definition of even integers, I've taken n equals to 2i and m equals to 2j, where n and m are integers. Now by definition of odd integers, a equals to 2p plus 1 and b equals to 2q plus 1, where p and q are integers. Now by substituting these values in the equation an plus bm, I'm getting 4pi plus 2i plus 4qj plus 2j by the distributive law of algebra, and then by closure property I'm getting the last equation. Now suppose that this equation is an integer and I'm assuming it to be some constant, that is suppose c over here. So thus I get an plus bm equals to 2c, which is an even integer. Now my case 2 says that a and b are even integers. So by the definition of even integers, I've taken n equals to 2i and m equals to 2j, where n and m are integers. So by definition of even integers, I've taken a equals to 2p and b equals to 2q, where p and q are integers. So the sum an plus bm is in this manner by substituting these values, and then again over here I'm using distributive law of algebra and the closure property. So as you can see that the equation is a part of integers and I'm assuming it to be a constant, so my sum an plus bm is again 2c, where 2c is an even integer. So now case 3. Now case 3 says that a is an odd integer and b is an even integer. Now by the property of even integer, by the definition of even integers, I can say that n equals to 2i and m equals to 2j, where n and m are integers. And by definition of odd and even integers, a is equals to 2p plus 1, that is odd, and b equals to 2q, that is even, where p and q are integers. Now by substituting these values in the equation an plus bm and by using the distributive law of algebra and the closure property, this is what I get over here. And then the sum is again 2c, which is an even integer. Now case 4 says that a is an even integer and b is an odd integer. So now by the definition of even integers, n equals to 2i and m equals to 2j, where n and m are integers. By definition of even and odd integers, a is equals to 2p and b equals to 2q plus 1, where p and q are integers. Now by using these values and substituting them in the equation an plus bm, this is what I get, and I'm using the distributive law of algebra and the closure property over here. So my sum comes up to 2c, which is an even integer. So I can say that by considering the 4 cases, that is, if n and m are even integers and a and b are integers, then the sum an plus bm is even. That is, p implies q. Thank you.